Next topic is equation of tangent plane to the sphere. So first, suppose the sphere equation of sphere in standard form. So question is find the equation of tangent plane to the sphere x square plus y square plus z square is equal to a square or r square at the point x1, y1, z1 on it. Now we have to find the equation of tangent plane to the sphere at the point x1, y1, z1 on it. That is the point lies on the sphere. And the equation of sphere is in the standard form. So the second theory is what? In the second theory, the equation of the sphere is in the general form. And the third one is what? The condition of tangency. So these three theories are important as far as the exam concerned. So question is what? Find the equation of tangent plane to the sphere. The previous topic is what? The equation of tangent line to the sphere. This is what? The tangent plane to the sphere. So the first theory is what? The equation of sphere is in the standard form. That is the center of the sphere is 0, 0, 0. Origin is the center. So the proof of this theorem, let p x1, y1, z1 be point on the sphere x square plus y square plus z square is equal to a square. Then we have what we have x1 square plus y1 square plus z1 square is equal to a square, equation number 2. This is equation number 1, suppose. As the point lies on the sphere, the point satisfies the equation of sphere. We have this x1 square plus y1 square plus z1 square is equal to a square. The equation of line passing through point x1, y1, z1 is what? X minus x1 by L is equal to y minus y1 by m is equal to z minus z1 by n. Obviously, there these L, m, n are the direction ratios or direction cosines of the line, not necessarily direction cosines. Element may be direction ratios of the line. So this x1, y1, z1 is point on the sphere. Now uh, this is the equation. If equation of line passing through point P x1, y1, z1 is what? This is the equation of the line passing through point in the symmetrical form. So x minus x1 by L, y minus y1 by M, z minus z1 by L. Now we will find the locus of this line. That is the, we get the equation of plane. So this point is lies on the sphere. Now this line become a tangent to the sphere. Is tangent line to the sphere because this line touches the sphere in only one point, or cuts the sphere, intersects the sphere in only one point x1, y1, z1. So now this line becomes a tangent line to the sphere. Now we find the locus of this line. So x minus x1 by n, y minus y1 by m, z minus z1 by n. So instead of this LMN, we can also use another notations like ABC. But here is A. If the equation of sphere, suppose the equation of sphere is x square plus y square plus z square is equal to r square, then we can use in the place of LMN as small ABC or any other notations. And x1, y1, z1 is the point on the, now this line becomes a tangent line to the sphere. So suppose this all this ratio is equal to r, say r, then value of x is what? x1 plus lr or lr plus x1, y is y1 plus mr. By comparing y minus y1 by m is equal to r, then by comparing z minus z1 by n is equal to r, we have z is equal to z1 plus r. Z1 plus ENR. So therefore, the coordinate of general point on the line, this line 3R in round bracket x1 plus LR, comma y1 plus MR plus Z1 plus ENR. If this point lies on the sphere, so if this point lies on the line, lies on the sphere 1, we have what we have, the this point satisfies the equation of sphere. That is, substitute x, y, z as x1 plus LR, y1 plus MR, z1 plus LR. So what do we have? X1 plus LR bracket square plus y1 plus MR bracket square plus z1 plus NR bracket square is equal to a square. So if we observe this procedure, then the procedure of finding equation of tangent plane to the sphere and the procedure of the problem of the tangent line to the sphere. Both are same. That is the equation of tangent equation of line. We compare with r each ratio, then find the coordinate of general point on the line, and if the point set lies on the sphere, then we have. So the procedure of the tangent line and tangent plane, the proof of the same are same. That is the procedure are same. Now we will find the locus of this point, this line of tangent line. So the coordinate of the general point on the line are x1 plus lr, comma y1 plus mr, comma z1 plus nr. If this point lies on the sphere, we have the equation of sphere satisfied by this point. So substitute x, y, and z these values. So we have this. After squaring this bracket, we have x1 square plus 2 x1 lr plus l square r square plus y1 square plus 2 y1 mr plus m square r square plus z1 square plus 2 times z1 nr plus n square r square is equal to minus a square by shifting this a square to LHS is equal to 0. Then collect the coefficient of r square, that is l square plus m square plus n square as the coefficient of r square. Then terms of r, take r as common. So we have 2x1 plus l, 2y1 plus m, 2z1 plus n r, then plus the remaining terms x1 square plus y1 square plus z1 square minus a square. And we have the, if you observe the procedure of the previous problem, that is the problem of the type tangent line to the sphere, then same procedure, that is the collect the coefficient of r square, then r, and then constant terms. So if you observe this problem, then what is the procedure? We have the equation, quadratic equation in r, quadratic equation r square term, r term, and constant term, remaining terms. So same procedure is here, that is the collect the terms of r square, then r, and then remaining terms, constant terms. So we have this l square plus m square plus n square. There is not necessarily one. Don't write l square plus m square plus n square as one. If L M N are the direction cosine, then we have l square plus m square plus n square is 1. But these L M N are direction ratios, not necessarily direction cosines. Then take 2 common from this. So 2r in bracket we have x1l plus y1m plus z1n plus x1 square plus y1 square plus z1 square minus a square. And the value of x1 square plus y1 square plus z1 square minus a square is 0 by using equation number 2. So substitute the value of this bracket as 0. We have this. Now from these two bracket, take r as common because we have to find the values of r. So take r common from these two. So we have in square bracket r, if you take r square from r square, if you take r common, then we have l square plus m square plus n square into r. Then 2, this r is at this place. So in plus 2 in bracket x1 l plus y1 m plus z1 n, bracket complete, from bracket complete, square bracket complete is equal to 0. So if we find the root of the this equation, that is the values of r, then obviously we have one root of this equation as r is equal to 0. We have the one root of this equation as r is equal to 0. So in order to, the line is tangent to the sphere, this line is tangent to the sphere, what happened? The other root must be 0. Because when the line is tangent to the sphere, we know that this procedure. If we have the two different values of r, then line is not tangent to the sphere. When the line is tangent to the sphere, if the both the values of r are same. So here we have one root of this, or one value of r is 0. Therefore, the other root of this equation also 0, must be 0. In order to line 3 is tangent, that is this line is tangent to the sphere, the sphere number 1, when if the another root must be 0. That is, we have this r is 0. Therefore, we have 2x1 in bracket x1 l plus y1 m plus z1 n is equal to 0. So when you substitute r is equal to 0 in this, we have this is equal to 0. That 2 in bracket x1 l plus y1 m plus z1 n is equal to 0. Okay, the other when the other root is 0, if this is 0, then other root is 0. Otherwise, we have the value of r as this minus this divided by L square plus M square plus N square. Okay, so in order to the other root equal to 0, this is equal to 0. Then we have the how we can find the root of this equation. R is equal to 0 and this bracket is equal to 0, means R is this quantity divided by L square plus M square plus N square R. But if it is 0, then we have the other root is 0. So in order to another root equal to 0, this value is 0. So we have this is equal to 0. If the one root is 0, R one value of R is 0, and so the second value, another value of R is also 0. If we substitute here 0, we have this is equal to 0. That is x1L plus y1M plus z1N is equal to 0. Then eliminating L, M, N from 3 and 4. So this is the equation number 3 and this is the equation number 4. So from 3 and 4, eliminating, that 3 means the equation of line, eliminating L, M, N. So we have the value of L as x minus x1 by R. Substitute x minus x1 by R as the L value of L. Then value of M is what? Y minus y1 by R. Substitute here value of M as y minus y1 by R. And substitute N as the value of N as, by equating these two, we have N as z minus z1 by R. So we have this equation z minus z1 by R value of N is equal to 0. Then multiplying throughout by R, we have this, and then simplify. We have x1, x minus x1 square, y1 minus y1 square, then z1 minus z1 square is equal to 0. And therefore we have x1 plus y1 plus z1 is equal to, shift this three quantity negative quantity on RHS. We have x1 square plus y1 square plus z1 square, and this x1 square plus y1 square plus z1 square is a square by using equation number these two. So we have x1 plus y1 plus z1 is equal to a square, and this is the required equation of tangent plane to the sphere. What is the equation of sphere? X square plus y square plus z square is equal to a square, and the equation of tangent plane to this sphere at point x1 y1 z1 is what? X1 plus y1 plus z1 is equal to a square. So this is the equation of tangent plane to the sphere. Obviously this is the equation of plane because it is in the form ax plus by plus cz plus d is equal to 0. If you shift a square onto LHS, then d is minus a square is equal to 0. So this is the equation of tangent plane to the sphere. So same procedure is applicable to this example, theorem number 2, that find the equation of tangent plane to the sphere. Now the equation of sphere is in the general form. X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 at the point x1 z1, x1 y1 z1 on it. So same applies, same procedure. So first let p x1 y1 z1 be the point on the sphere. X square plus y square plus z square plus 2x plus 2vy plus 2wz plus d is equal to 0. Equation number 1 we have. So this point lies on this sphere, therefore we have this point satisfies the equation of sphere. We have x1 square plus y1 square plus z1 square, that is substitute x, y, z as x1 y1 z1. Then the equation of line passing through the point P x1 y1 z1 is what? X minus x1 by L, y minus y1 by M, z minus z1 by N is equal to R. Say equation number 3 like this. Same procedure. That is substitute the is equal to, compare is equal to R, x minus x1. This is the equation of line passing through this point in symmetrical form. Obviously this point P x1 y1 z1 is point on the sphere, therefore this line becomes a tangent line to the sphere. Now we will find the locus of this line. So LM and R obviously direction ratios of the line. Then the value of x, by comparing x minus x1 by L is equal to R, we have x is equal to x1 plus LR, y value of y, value of z R is z1 plus LR. Then the coordinate of the general point on the line are what? X1 plus LR, comma y1 plus MR, comma z1 plus NR. If this point lies on the sphere 1, we have the same procedure. That is, if this point lies on the line lies on the sphere, then we have what we have, the equation of a sphere. This equation of sphere, equation number 1, satisfies by this point coordinates. That is, substitute x as x1 plus nr, y as y1 plus mr, and z as z1 plus nr in the equation of sphere. We have this, that x1 x square y square z square 2u x value of x, 2v y value of y, 2w value of z plus d is equal to 0. And find the square of these brackets. We have these terms, then multiply by 2u, multiply by 2v, multiply by 2w in the bracket. We have all these terms. Then collect the coefficient of r square, or terms of r square. So we have there are three terms, L square r square, m square r square, and n square r square. So take r square as common. We have L square plus m square plus n square in bracket, plus the terms of r, or 2r. So what are the two r terms? So this is x1 plus L, this is y1 plus m, this is z1 plus n, then this term ul plus vm plus wn. These are the terms. Take 2r as a common factor. And then the remaining terms. What are the remaining terms? x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d is equal to 0. Okay. Then we have L square plus m square plus n square r square plus 2r in bracket x1 L plus y1 m plus z1 n, then ul plus vm plus wn, plus the value of this bracket x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d. Value of this bracket is what? 0, by using equation number 2. As this point x1 y1 z1 lies on this is the equation number 2. The value of this bracket is 0. Then we have the equation L square plus m square. Substitute the value of this bracket as 0. Then we have the value L square plus m square plus n square r square plus 2r in square bracket. Then x1 plus L and ul, take L as common. So we have in bracket x1 plus u. Then y1 m and vm, take m as common. So we have y1 plus v. Then take n as common. So we have in bracket z1 plus w, square bracket complete, is equal to 0. Then take r common from these two. We have in square bracket L square plus m square plus n square r in another bracket plus 2, like r as common. So in bracket we have L, the remaining terms is equal to 0. And then obviously if you find the values of r from this equation, we have one root of this equation as r is equal to 0. So in order to, line 3 is tangent to the sphere. So when the line is tangent to the sphere, this line 3 is tangent to the sphere if the line intersects the sphere in only one point. Okay, and when this happens, if the other root of this equation is also 0. So in order to, line 3 is tangent to the sphere, the other root must be 0. And therefore we have, when the other root is 0, when the value of this r is 0, if this value, this quantity is 0, that is 2 in bracket L x1 plus u plus m y1 plus b plus n z1 plus w is equal to 0. So 2 is not equal to 0, shift 2 to RHS. We have L in bracket x1 plus u, m in bracket y1 plus b, n in bracket z1 plus w is equal to 0. Then eliminating L, m, n from 3 and 4. That is, find the value of L from equation number 3, which is what? X minus x1 by L is equal to r, gives L is x minus x1 by r. Substitute L as x minus x1 by r. Here the value of L as x minus x1 by r. Similarly, value of m is y minus y1 by r from equation number 3, and from value of n is z minus z1 by r. Z1 plus w is equal to 0. Then multiplying throughout by r, and we have this. Then multiply these brackets. We have the 4 terms. 4 plus 4 plus 4. We have 12 terms total. Then arrange the terms, that x x1 plus y y1 plus z z1 plus u, these terms xu and the term xu and x1u, like x as common here, right, plus side. So we have x plus x1 in bracket, then v term, if you observe the v term, yv and y1v. So x1 yy1 plus zz1 ux vy. Now don't write this step. After this step, write this step, that zz1. Then shift all negative terms to RHS. So what we have, ux plus vy plus wz is equal to x1 square plus y1 square plus z1 square plus ux1 plus vy1 plus wz1 plus d. So I shift all the negative terms to RHS. Don't write this step. After this step, write this step. Then add ux1 plus vy1 plus wz1 in LHS and RHS. So write ux1, add ux1 plus vy1 plus wz1 in LHS and RHS. So what is the RHS? Now x1 square plus y1 square plus z1 square. Ux1 plus ux1 become 2ux1. Vy1 plus vy1 becomes 2vy1 and wz1 plus wz1 becomes 2wz1 plus d. So add these terms ux1, vy1 and wz1 in LHS and RHS. And then we have xx1 plus y1 plus zz1, and then now this ux and ux1, take u as common. We have x plus x1, then v as common, y plus y1, w as common, z plus z1 plus d, and the value of RHS is now 0 by using equation number 2, x1 square plus y1 square plus z1 square plus 2ux1 2vy1 plus 2wz1 plus d is 0. And so this is the equation of tangent plane to the sphere. So what is the equation of sphere? X square plus y square plus z square. So x square is replaced by xx1, y square is replaced by yy1, z square is replaced by zz1, and 2ux. So u is as it is. So 2x is replaced by x plus x1, 2vy. So v is as it is. So 2y is replaced by y plus y1 and 2wz. W is as it is. So 2z is replaced by z plus z1 plus d is equal to 0. So this is the equation of sphere. This is the equation of tangent plane to the sphere in the general form, that is x square plus y square plus z square plus 2x plus 2y plus 2wz plus d is equal to 0. So we'll see the problem on this two topic in the next lecture.